High above sun-drenched meadows in summer, a common cabbage white butterfly, Pieris rapi, flutters past a cluster of wild mustard flowers, its wings beating 10 times per second. What happens next defies intuition. Tiny pollen grains leap from the flower's anthers across a millimeter-wide air gap, drawn irresistibly to the butterfly's body like iron filings to a magnet. These unbelievable animal facts reveal the only pollinators known to harvest nectar remotely using electrostatic telekinesis, a force invisible to the human eye but powerful enough to bridge the void between insect and bloom. Discovered in July 2024 by researchers at the University of Bristol, this aerial electropollination occurs in over 90% of butterfly and moth species, turning flight itself into a superpower for survival in extreme environments where direct contact risks predation or energy waste. The mechanism is rooted in the physics of flight. As wings slice through the air at speeds up to 5 meters per second, friction with atmospheric molecules strips electrons from the insect's chitin exoskeleton, charging it positively to up to 1,000 volts, equivalent to a mild static shock, but sustained across the entire body. Pollen grains, oppositely charged by the flower's own bioelectric fields, experience an electrostatic pull 100 times stronger than gravity at close range. High-speed imaging shows grains accelerating from rest to 0.5 millimeters per second in microseconds, adhering to fuzzy wing scales or leg hairs without the butterfly ever landing. This animal adaptation allows efficient foraging. A single butterfly can collect pollen from dozens of flowers mid-flight, boosting reproductive success by 20 to 30% in wind-swept habitats where hovering is metabolically costly. Unlike bees, which use electrostatic attraction only upon landing, lepidopterans exploit it dynamically in 3 dimensions. Phylogenetic analysis of 50 species confirms the trait evolved convergently in butterflies, Papilionoea, and moths, Noctuea, with charge buildup scaling to wingspan. Larger swallowtails generate fields strong enough to draw pollen from 2 millimeters away. In lab simulations, neutralized insects gathered 40% less pollen, proving the charge's necessity. This survival in extreme environments extends to nocturnal moths, whose darker exoskeletons retain charge longer in humid nights, enabling pollination in low light where vision fails. Yet this genius of aerial electroreception faces peril. Climate change amplifies atmospheric ionization from storms, scrambling the fields and reducing pollination efficiency by up to 15% in affected regions. Pesticides laced with conductive nanoparticles disrupt the charge balance, causing pollen to repel instead of attract. Habitat fragmentation forces shorter flights, weakening the triboelectric effect that powers this telekinetic harvest. These weird animal facts shatter the myth of passive pollination. A creature weighing less than a paperclip, evolved from ancient crawlers 300 million years ago, now commands invisible forces to feed an ecosystem. Every flutter isn't just motion, it's a calculated electromagnetic conquest, reminding us that nature's true magic hides in the static hum of wings. In a world racing toward silence, the butterfly's electric whisper ensures flowers bloom where no touch has gone before.